Greetings, Earthlings.
Well, we visited Ryan Nagata's shop, and I am wearing the beautiful AL7 suit that he made for me. And we'll do a separate video that covers the beautiful features of this suit. But for right now, my one-day build today is I'm going to make some parts for this suit. First and foremost, he's got a wonderful bit of accuracy here, and that in this leg pocket, there is a port right here, and that port houses what's called a dosimeter. It's a radiation dose detector, and it tells you whether the dose of radiation you've gotten is safe or past the norm. So I'm going to make a master pattern of the dosimeter and send it to Ryan for casting and detailing. Secondly, I am going to make some knobs for what's called the RCU. This is the remote control unit that sits in the front when you're doing extravehicular activity. These are some wooden masters that were what he had. I'm going to remake these out of aluminum at a much higher fidelity to the blueprints that we have from NASA, because we have some blueprints from NASA. And that's the one-day build. It's going to build probably 4 separate little parts. It's almost all going to be on my milling machine and my lathe. Let's get started. First up, I got to get out of this suit. All right, the first part I'm going to replicate is this. It's got 8 little detents around it and details here for knurling, for turning this knob. This is the most complicated part I'm going to make today, so I'm going to make it first because I like to do the hard stuff up front. I'm going to be using my dividing head on the mill, but first I'm going to turn the material down to the correct diameter. That's this heavy aluminum stock on the lathe. Let's get started. Yeah, okay. 1.9 inches in diameter. So this is going to be 2. So I just want to pull off 100 thou. Double check my measurement there. There she blows. All right, let's see here. Center drill. Check that. Oh yeah, good, good, good. This operation of using a cutoff tool to separate a big piece of stock from the lathe, one of the scariest operations for me. I just don't like doing it, so I always do it at a very slow speed. It means nothing gets too far out of control. And I use lots of coolant. Keep my blade sharp. There it comes. There we are. Beauty. Okay. Over to the mill. That right there is an indexing head. You're about to see the wonders of this machine. I love it very much. I want to set this 0. Great. Yeah, that should do it. So there's 8 of them. Coming at 1/8 of an inch. A little less, 0.1, 100 thou. Okay. So what I need to do is to make these circular detents times 8 all the way around the perimeter of this stock. The way I'm going to do that is I'm going to plunge this 1/2 inch milling bit 8 times down. Now I'm going to make sure it's in the exact right position by using this index head and turning it. Now I have 8 detents to carve around a 360-degree perimeter, which means I'm going to plunge one every 45 degrees. I'm going to make sure it's exactly 100 thou in. So I'll do this and turn this until it's there. Bring this into, there we go. Okay, now I'm going to lock my milling table so it can't move. I'm going to set this at 0. And I'm going to lock it as well. It's always good to lock everything down so as little can move as possible. There we go. Here comes the first cut. Beautiful. Set that depth right there, so I can't go lower than that. Excellent, then it'll all be the same. Unlock, turn 45 degrees. Unlock, 45. There we go. Lock and plunge. Unlock. 45 more degrees, this time to 90. Lock and plunge. Excellent. Now I have to carve these lines in the same piece. And this is actually quite a different operation. This is going to be trickier. I'm going to have to do a little math to start, and then I'm going to have to set this. It's a long story, but basically I'm going to put a right angle horizontal milling attachment onto the spindle of this, lower this, and make this horizontal so I can use a slitting saw. Here we go. Let's see if this... All right, let's give this a shot. It's always good to lock everything down so as little can move as possible. Milling operations are the very definition of measure twice, cut once. And I measured everything and got it all pretty in line to make my first slice cut here. And then I forgot to lock that down. Yeah. So I cut this piece wrong, and now I have to do this again from scratch. What a bonehead. What a frickin' bonehead. Here we go. All right, I'm back to zero. I have made my flute cuts here with a 1/2-inch milling bit, and I'm about to try and cut the lines again. Let's see if I can get it right this time. .36. So that's also 0.36. So 0.18. Let's see. Come in. All right, so I'm getting my positioning close here. Here's the thing. This is a piece of aesthetic hardware, so I don't have to be crazy precise, but visually I need to be pretty darn precise. So I think I'm dialed right in here. The question is, how far? Now, how deep do I want to go? And the answer is, I want to go really about, what about 30 thou? Yeah, 30 thou. Okay, so if I dial this in to 0, and I've got that, and I dial this up 20 and 30. So that'll be the cut. Locked, 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 locked. Double check. Locked. Locked. Good. All right. Let's see what we got. Ah! Ha! Ha 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 ha! I hadn't locked that in. Nice. Okay. Okay. Good thing I checked. I want to be right on the center there. Hold on. One last little. So close. Okay, good. Locking that. I'm going to 0 that. Put that there. Come back here. Come back up. And lock. And where do we stand here? Okay, here we go. Back to 0. I'm locked there. Up 30 thou. And here we go. That looks darn good. So now 22 and a half minus 6 equals 16.5. 16.5 and 112 is 106.5 and 118.5. $96.5, 331.5, and 343.5. All right, here we go. Let's see here. 16.5. All right, I've messed it up again. Cut to a close-up. Yeah, you can see how it's just totally off kilter. My problem is my registration on what is center and what is not is messing up. So I need to rethink my set of operations here. I know there's some of you actual machinists out there who are like, you idiot, all you need to do is blah, 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 blah. And that's the problem of being a generalist. I didn't think this all the way through. So I'm going to rejigger. And I think I'm going to pull out this right angle arrangement and stop using the slitting saw and start using a nice thin baby milling bit so that all my operations are down and I only ever have to center this thing once and that's it. That's the trick. It's the switching operations that's messing me up. So, once more into the breach, dear friends. Okay. All right, now to cut the circular flutes. So I changed my order of operations. In the beginning, I cut the semicircular flutes out of the side first, and then I was cutting little knurling slots, and I was having trouble aligning. So this time I cut the knurling slots first, and now I'm cutting the semicircular flutes. Hopefully that'll give me a little better control, and I'll be able to see that I'm screwing up before it's past the point of no return. 2 bad attempts so far, I don't want a third. Tool of choice now is a ball end mill. And I haven't moved any of my arrangements. I haven't had to reset my XY table here. And that's pretty important. That is pretty darn important. $45. That's the next one. Next one is 90. Next one is 315. And that's the last one. That might be it. I might have gotten all the cuts. Let's double check. That looks pretty darn good. All right. Awesome. Whew. Whew. That was a much tougher job than I thought it would be. Good, good, good. Okay. 0.43 inches thick. That's where I'm at. We make this final cut. This part is done. I don't mind telling you, I'm happy to see it go. Awesome. All right. A little bit of finishing. Looking good. Next part. Now I'm making this part, the little dial knob that goes on top of this. I want to make this one out of Delrin instead of aluminum because I want my life to be a little easier. do here? There is the knob, and I'm very happy with that and how that looks. It's a nice little part. They fit together well. Now I've got to do a little bit of detailing. I've got to drill a couple holes and then we're done. I'm going to drill one hole right there. Is that 40, 40, 40, 40? Okay. I have carefully made this dial in Delrin, and I've accidentally combined features of both the dial at the top of the remote control unit and the bottom. I've made an amalgam of both of those dials, and this doesn't work for either one. I'm out of sorts today. This is just one of those days when nothing's quite going right. I'm pretty frustrated. I'm just going to get back to it. Oh! Just a little relaxing millipede before I get back into it. It's like that bit in The Office when she's like, my plan for this race is to run really fast at the beginning and then run really fast in the middle and then run fast at the end. the last cut. That was it. Let's see if I can open this up. You are pretty darn good. My dials. They're mostly done. Got just a little bit of a ding in there. I'm going to fill it with the acrylic from the cyanoacrylate glue, or crazy glue, and then I'm going to sand it down. For those of you who are wondering if my frustration was real, it was. But, you know, there is something that you learn when you do this stuff poorly, which is the order of operations. I was making all my cuts kind of bass-ackwards. So now I have a better understanding of how to kind of think through a shape like this when you're making it, and consequently, I'm a little better for it. Yeah. Nice. Awesome. All right, the last bit of Apollo hardware for this one-day build is the dosimeter, actually the dosimeter pattern master. Now, the dosimeter went in this right-hand leg pocket of the astronauts, and it told them how much radiation they were getting. There's no protection from solar radiation and cosmic rays on the moon. Astronauts need to know how much they're getting, and the dosimeter told them. It's a little device. Now, I've had some trouble figuring out the exact dimensions of a dosimeter, but luckily one just came up for auction, and they listed its dimensions. So I'm going to pull it up on my computer, make some notes, and we're going to make it out of one of my favorite materials I have not yet used untested. All right. So what is up for auction is Deke Slayton's personal radiation dosimeter. It is a fairly simple soap bar shaped object, and the auction listing says it is 2 1/4 inches by 3 inches by 3/4 of an inch. That is everything I need to replicate this. Now, it also has a little display of numbers, but I think we're going to cheat that. Again, I'm making a pattern master to send to Ryan Nagata, who will make, mold, and cast these, and also do the what do you call them? The foil stickers for them. So let's get started. I know that as somebody who started out working in a home shop with very little budget, I love the cheap and easy materials. This is not one of the cheap materials, although it is one of the easiest. This is a product called RenShape, and it's expensive and amazing. RenShape is effectively a prototyping urethane plastic. It has a difference over any kind of wood in that it has no grain, and wherever you finish it, it finishes uniformly. So you can make smooth shapes out of this stuff all day long. This is one of the cornerstones of high-end special effects model making, because you don't need to do a lot of finishing work once you've carved your basic shape, and that's worth its weight in gold in terms of time. The expense comes in the material itself. This sheet right here, which was originally about this big, it's like $300. It's a lot of dough. But I probably won't work through this sheet in my lifetime for the kind of model making I do. Right now for the dosimeter, I'm going to use a little tiny piece about this big. I'm going to saw it off using a Japanese handsaw. So RenShape is very specifically made as an engineering and prototyping material. It's specifically formulated so that it doesn't dull your milling bits, that you can saw it, sand it, carve it. I mean, it's really, really amazing stuff. I haven't used it a bunch on the tested because, well, it is one of the sort of more materials of the deeper pocketed shops. But boy, I love this stuff. In fact, at a place like Industrial Light and Magic, kind of moving so fast, I'm a little impatient. At a place like Industrial Light and Magic, they will use large chunks of this and not consider the smaller chunks worth saving. And so, like my friend Fawn Davis and I used to go through the dumpster and collect little chunks for our model making shops. That's my chunk. I'm going to put the bigger piece away now. Now, I'm not just making a single blank for this master. I'm going to start by making 3 of them. I know from hard-won experience that I'm likely to screw this up, so I'm going to take it carefully. All right, I want 2 1/4 by 3 by 3/4 of an inch. Again, I save every chunk of wrench shape. It's precious, precious gold. Here's my thing. I could make more of these cuts on the table saw, but I hate working with the table saw with the blade this high. It sort of freaks me out. So I'm going to pause on this and I'm going to move over to the bandsaw. Just feel a lot better that way. Should be able to get 4 prototypes out of this. Always better to have too many to start with than too few. All right, to the bandsaw, boy wonder. Now I'm off to the disc sander to make all my edges perfectly square. Nice. You see how easily the wrench shape actually sands. This is both its awesomeness and the thing that's most dangerous about it is that it sands so quickly you can actually take off more material than you want. Oh, nice. Awesome. Good. Wait a second. Better. That's a B grade piece. There she blows. All right. So here's the reason I went for 4, because out of the 4 pieces I cut, 3 are really tight and great. 1 is just okay. So I'm going to toss this one out, put it in the wrench-shaped scrap pile. My disc sander is about 120 grit. I want these to be smoother, so I'm going to take them further down on a 180 grit piece of sandpaper. Make them really nice. This is going to be a casting master, and even though Ryan's probably going to coat it with primer, I want it to be really nice. I agree with you. That does sound like farting. Let's see where we're at. Great. Great. Awesome. Awesome. In every case, I'm within 10th thou, which for a model like this is just great. Me, clean up and take a shop shower. So I see a few details here that are worth noting. I see some circles on the top. I see a place where the numbers go. So let us, yeah, I think that we can stick a little piece of acrylic in there with a sticker behind it and we should be good. Now, the way I'm going to figure out the size of this is actually, I am going to just get it to be the correct size on my computer screen and measure it off of that. It's, you know, if I had a lot of time, I would go towards, there we go. If I had a lot of time, I would go towards printing this out, but this should be just fine. So, my number screen is centered. We're good. Okay, cool. So, my number screen is ½ inch wide. How tall is it? .2, and it is how far from the top? All right, that is a much smaller little number counter than I thought it would be, but apparently that's the size it is. Let me just double check this with some of my other reference material. Yeah, you're pretty close. ½ inch wide. Yep. Okay. This is a piece of reference I gathered a few months ago. It's not quite as straight on a shot as the one I just got from the auction, but it confirms my measurements for this. So this right here is the window that I'm going to cut out. But just for double, triple, quadruple checking, I'm going to put it in the pocket where the dosimeter actually goes and see if it fits Ryan's sewing pattern. Let's see here. Oh, right, I've got to soften the end. That's for sure. But if I do, yeah, if I soften the end, the display shows up right in there. That's just where I want it. So we should be good. Excellent. I think it's time to start machining. All right. This is a very tiny machining operation, so I'm going to use a tiny milling bit. That is a tiny milling bit. It's 1/16. I'm only going to go in about 1/8 of an inch. Yeah, about 1/8 of an inch and carve out this little hole. If I was doing an actual bit of mechanical machining, like a machine that had to work together, I would do a couple things. One, I would tram in my vise so it was accurate to less than 1,000th X, Y, and Z. This is just a prop. I don't need to spend the extra half hour doing that right now. Second, I would probably take some critical measurements and use my DRO to make sure the box I'm making is exactly the right size. But for this one, I'm just going to use my eye because that's going to be plenty good enough given my pencil lines. Okay. It's 100 thou, 120, and 5. There we go. That's a full 1/8 of an inch. All right, there's a corner. I'm going to set it at 0. I've got to proceed slowly. I don't want to break this bit. That is great. That is a lovely 1/8 inch deep hole. I don't even see that I need to square off the edges. That's a nice little bit of detail. All right, now for the circles. All right, now this is, there we go. Excellent. Okay, cool. So now, how wide are these screw heads? Bingo, it's 256. Wow. That is 0.6. 0.6. Good. I like that. All right, so that's going to be my 0 point. These are just going to be plunge cuts like this. Then I'm going to move up 0.6. All right. Yes. Those should be my 4 countersunk holes. Those look beautiful. Just take a moment to take a look at these really nice and close up. They're really pretty. I'm kind of proud of them. They don't need to be these. They could be the shorter ones. No, that's no good. No, shite. Ah, bellissimo! If I was doing mechanical stuff, I'd be threading these and being a little more careful, but because this is just a visual piece, it's just aesthetic, I'm being a little looser with some of my tolerances. But again, this is looking darned good. We're going to do a test cut on this before I cut this, because I've already put so much time into this, I don't want to screw it up. So I'm going to do a test cut on my secondary piece. Well, that seems to make a very nice, gentle cut, and it's damn close to the edges, so I think we're pretty good. I think I can actually, it's just roughly where I want it, nice and centered. I should be pretty good here. All right. I'm terrified of this cut. I don't mind telling you, but let's see what we can do. Here we go. Awesome. Woo! All right. Now lastly, I want to make that battery cover. I'm going to do it on the lathe. How am I going to make a wren-shaped plug that fits that exactly and looks just like the battery holder? I'm going to do it by using a circle template and some wren shapes. So check this out. Here we go. I'm going to draw that, and I'll draw a second one just for good measure. To the bandsaw. to the belt sander. Did I say belt sander? I meant disc sander. Now, I didn't need the tube that I was cutting, the rod of wrench shape, to be absolutely perfect. I just needed it to be close enough so I could stably grab it with the 3 jaws of the chuck of my lathe. Now I'm going to machine it down to exactly 3/4 of an inch so that it fits the hole exactly. Now, before I cut this down to size, I need to cut a slot in its end, specifically a coin slot, so that you could use a quarter to open it, as it seems you can on the dosimeter. There it is. That's what I wanted. Is that what I wanted? That's it. There she blows. Good. There we go. Excellent. I'm going to lock that, turn that. Now, I cut this off and put it in my lathe and slice the piece. Ah, look at that. It's beautiful. All right, I'm going to sand this whole thing down. Now to sand down the bottom of my dosimeter. All right, now I want to crazy glue in the battery holder. 1 drop ought to do it. Do it on a nice angle there. And there it is. That's the last of the Apollo objects for today's one-day build. Now I want to add a little coda on this. We actually shot this over 2 days. I know we called it a one-day build. In the end, it was about 8 or 9 hours worth of work, Joey? Yeah, 8 or 9 hours. When I finished screwing up those dials, like I built each one 3 times and kept on munging them, it was actually one of those dark days of making stuff where I had finished and I literally had this thought, I don't know what business I have making stuff. I seriously had this thought. It's ludicrous, right? I mean, it's ludicrous. It's ludicrous for anybody to think that. Like, this has been my living, and yet I was brought so low by screwing those things up so many times that I had a real dark day. I was real blue when I went home. Chilled out, had some tea, had a good night's sleep, came back today and got back into it, and now it's better. I just want you to know that that kind of thing happens all the time to everybody. Nobody escapes that kind of feeling in the shop of, man, why do I keep screwing stuff up? I just wanted you to know that.